Hello guys, let's prove that x to the power n minus a to the power n is divisible by x minus a, where x is a variable and a is a constant. Now let's do this proof by using synthetic division. So let's first write the first statement of the proof. Let's assume that x to the power n minus a to the power n is divisible by x minus a. So what that means is x minus a is a factor of x to the power n minus a to the power n. What that means is that if we put x equals to a, that means the whole remainder that we get is 0. And let's do synthetic division, but first let's find out how to do synthetic division for a polynomial expression like this. There is x to the power some power missing in that expression. So let's take an example, x cube plus x plus 1. So how do you do synthetic division? Let's say you took 1, x minus 1, and here for the synthetic division what you do is you put x minus 1 equals to 0, x equals to 1, and then here you put 1 here like this, and from increasing to decreasing order of the power of x, and in the end you have a constant, you put them down, x cube, and then as you can see we have no x square, but still you have to write that down. So x square, x, and finally the constant, which I'll write c. So here, then below of each of these powers you write their coefficient. So x cube, we have 1, and x squared. Well, you can write this as plus 0x squared, or if it feels easy for you, you can write this over here. So that means the coefficient is 0. So that means if any extra power, x to some power is missing, we can just write the coefficient as 0. For x we have 1, and for constant you can have 1, and if this was 3, you'll write 3. If this was minus 3, you'll write minus 3, like that. And same goes for each of these constants. Now let's write that down for x to the power n minus a to the power n. Let's begin. So we know that x minus a is a factor, so we'll have x equals to a over here and here. We'll first have x to the power n, and the next term or the next power will be x to the power n minus 1, since it's decreasing, and then we'll have x to the power n minus 2, and then we'll have x to the power n minus 3, x to the power n minus 4, and so on until finally you'll have the constant, which is a to the power n. Sorry, not a to the power n, we'll write c first, which stands for constant, and then below it we'll write a to the power n, well, minus a to the power n. Now before this constant, let's write the previous term before this, which will just be x to the power 1. It will just be x. It will be this, and finally you'll get x, and then you'll have the constant. Now let's do the synthetic division. So first, before that, I almost forgot, let's write the the coefficients first. So here we have 1 x to the power n, and for the rest of all of these we'll have 0, 0, the next one 0, and all the way, and even for this is also 0, and for the constant, our constant is this part, minus a to the power n. Now let's begin. I'll put this one over here, and before that let me just do this, and now this a will multiply with 1 and a will go right here, and then you add these terms, so a plus 0 is a, multiply, you'll get a squared, and these two add to give a squared, and then next this will be a cube, you'll have a cube, a to the power 4, a to the power 4, and so on. Now what will be for x to the power 1? Well, let's find some pattern here. So here, let's forget about this now. Let's look at x to the power n minus 1. We'll have a to the power 1, x to the power n minus 2, a to the power 2, or a square, and next for x to the power n minus 3, we'll have a to the power 3. And as you can see, for all of these terms, we'll have x to the power, for the powers of x to the power n minus something, the answer right here will be a to the power something. So what about x to the power 1? How can we write it as n minus something? We can write it as x to the power n minus n minus 1, since the n's will cancel and we'll have minus minus 1, which is just 1. And here this means we'll have e to the power n minus 1, and let's just write it over here as well. And finally, for the last term, a will multiply with this to give a to the power n, and here, as you can see nicely, these two add up, which is e to the power n plus minus e to the power n, cancelling each other gives 0. And as I mentioned earlier, this last term is our remainder. And if the remainder is 0, that means that this is a factor, which is true. And we can end our proof right here. That means x minus a is a factor. That means our initial assumption that this is divisible by that is true. So we can conclude that x to the power n minus a to the power n is divisible by x minus a. And if you want, I'll also write down the answer for you. What happens if you divide x to the power n minus a to the power n by x minus a? The terms you'll end up with is first, and for the answer you'll just have the powers shifted one power below, meaning we'll have 1 times x to the power n minus 1 plus a times x to the power n minus 2 plus a squared times x to the power n minus 3, and so on until here our constant remaining will just be a to the power n minus 1. And that is it. This is our quotient, our remainder is 0, and our proof ended here, but I just wanted to write it for you guys. And that is it. And next we'll be doing this exact same proof, but with mathematical induction. So if you guys done something new, please like and subscribe. Thank you.